Hey everyone, and welcome to Megashift today. I'm joined here with Mario Camaj. He is the lead consultant at Kormilo. We are really thrilled to have you today, Mario. How are you doing? How's your week going so far?
I'm doing great. Wonderful week here in New York. Great weather and looking forward for winter coming.
Yeah. Fall is one of my favorite times of year. So you hear those leaves crunch, and you know it's like it's time to think about the seasons changing. So really excited to have you share your expertise with viewers today. So welcome to Megashift. Speaking of the word shift, we have Megashift, and then you are the writer and curator of a newsletter called Tectonic Shift, which covers a number of different topics, emerging technology. So you're really like trend casting and doing a lot of analysis in this space focused on enterprise leaders, CTOs, architects. So, I wanted to hear a bit about your background and how you got into this space, and primarily what are some of the shifts that you're seeing today?
Sure. Great to be on the show today with you. We've known each other for a couple of years, and happy to see that you've ventured into this space. I guess a little bit about me. Again, Mario Camaj. I've been in the technology space for quite a long time. I think I built my first websites probably in like 1995, and my first probably paid engagement was in 1997, building websites in the HVAC space, actually, if I remember correctly. And the first startups were in the late 90s. So 1999, I was part of a core group. I think I was like employee number 4 of a company called Neomio, where we were building infrastructure for the email space. We were a SoftBank ventured business at the time, and ultimately that business ended up having some success, but it took quite a long time because we got hit by the 2001 .com bubble. But it was ultimately sold to Pastini, which was ultimately sold to Google. So it was an interesting time. I've ventured in and out of technology with various roles, primarily sticking in the financial services, education, and telecom space. Working both, at startups, like I said, Neomio. Another one was Global One, which was ultimately sold to Accenture. And also working for kind of the big financial firms like Deutsche Bank and JP Morgan Chase. Kind of in the middle there, I ventured over into the education space, working as a director of technology over at Columbia University, where I both attended a master's degree program and then later taught in that program. More recently, I've been back into the technology space again the last 7 years, focusing on various portions of infrastructure inside of telecommunications. And throughout the entire phase, I've also been working on various AI projects. Most recently, I'm working on building AI artificial intelligence applications for identifying and building to what we call BSLs, or broadband servable locations, across North America.
Wow. Yeah. What a journey you've had. And it sounds like you're really pioneering some of that infrastructure for these telecos, and that's expanding. I know you have had some coverage about quantum as a space too. And is there a connection between maybe quantum computing and kind of the computational resources that type of work you're leading now will require? Like, how did you kind of, what was the tip of the spear as you started researching quantum, or what are some of the different facets of the teleco industry that kind of led you to reading up on quantum and the current compute landscape?
Sure. So let me back up a little bit. I didn't mention the newsletter, Tectonic Shift. So the idea behind it originally was I launched the newsletter kind of in between the Christmas and New Year's holiday, as I was thinking about what 2025 and 2026 was going to look like. And the idea behind it was really, from the students that I've had over the years, and kind of what they should be expecting out of these 2 years. And I named it Tectonic Shift because kind of like the seismic shifts that are happening, on the planet Earth, technology, really driven by AI and quantum, are forcing a massive shift in the way that we approach development, the way that we approach the infrastructure that's going to support the development, and ultimately the interaction between what humans and machines will look like. And it's happening very, very rapidly, right? And so there was kind of the original goal behind the newsletter was really to formulate ways for people to upskill themselves to become part of this tectonic movement that's happening in the information technology space. As I've written articles and I've gotten feedback from my readers, and as the newsletter has grown, what I've found out is that there is kind of a deep, it's definitely niche and it's definitely narrow, but it's very deep in people really wanting to get, the kind of latest news and information about the core technologies that are driving this shift. And the ability to read an article that kind of deep dives into it, that has use cases and that maybe has some ability to upscale a person's both knowledge and then upscale a person's ability in that space. As we've seen since 2023, the sexiest technology, the thing that everyone is talking about, whether or not it's positive or negative or kind of in between, has been the artificial intelligence space. I've been looking at the artificial intelligence space for quite a long time. I probably started looking at it back in 1999 when we were doing the email infrastructure stuff, because we were actually looking at machine learning and how we could utilize machine learning to deal with email at that time. I've looked at it for various different computer vision type scenarios over the years, and we've definitely taught that class together with Professor Norm Jackness to various students, about the capabilities for the last 5 years, let's call it. Because of that shift, other technologies that have kind of been in the peripheral have started to accelerate as well, right? And what I mean by other technologies is that there was a massive shift into the cloud, right? In 2012 to 2020, all anybody really talked about was like cloud services and all of that kind of stuff, and that did fundamentally change how information technology is approached and ultimately how it's delivered to the end user. There's not a company today, there's not a startup today that's buying infrastructure and deploying infrastructure. They're all doing that on the cloud. And that was the last kind of massive tectonic shift in the marketplace. What we're seeing is the same thing happen because of AI, right? No one is starting a project without first approaching it from the AI perspective. So we're constantly using these tools in our day-to-day life. From the quantum side, quantum has been around for a while now, right? But the developments really haven't allowed for two things to happen. One, the utilization of cloud from a commercial perspective, because of the costs and abilities of quantum, have not aligned yet. On the other end of it, the technology that's supporting the kind of massive gains in quantum have only really come to fruition in the last 2 to 3 years, where you start to see kind of a forward adoption of the technology. But as we move towards more AI, there was a lecture that I had recently given about kind of what are the stumbling blocks of AI from a national adoption perspective. And it's expected that the United States will probably have about 4 to 5 super intelligence machines, right? So these massive data centers or massive combination of data centers that will support a super intelligence, the next the AGI, artificial general intelligence, is the next thing, and then after that it's the super intelligence. Well, the idea is that the United States will probably have 5 of those within the next 5 to 10 years, but to support those we need about 92 gigabytes of power to support them, right? So unless we plan on building roughly 100 nuclear power plants, we do not have the energy to support that type of thing. So what is the other avenue that we have to start to look at to support this type of superintelligence? And one of the main avenues for that is quantum, right? Can we utilize quantum computing to reduce the energy needs that would have otherwise been needed by AGI or ASI in the future? And the answer is probably yes. Now, it's not as kind of linear as like we could just switch from normal processing to quantum processing. It's the workloads that we can offload to do that. So if you think of what quantum is actually good at and where AI is kind of heading to, kind of in the short term, they start to converge. AI is really heading towards this concept of agentic AI, or agents that are working on specific tasks. The idea is that the agents will then start to create other agents which will help them roadmap where they need to go. Those types of workloads, that agentic recreation and running at kind of at the same time, but in quantum speed, really work towards the quantum computing arena. And so what you're seeing is a massive amount of people saying, hey, what types of workloads do I still need to have on traditional infrastructure? And what types of workloads can I offload onto the quantum infrastructure so that I can gain this capability without needing the same level of energy that I will need otherwise?
Absolutely.
And so those two things are starting to converge.
And I'm really glad you bring that up, of how there's this convergence. As we look at quantum, could you maybe talk a little bit about how quantum might apply to different industries and kind of contextualize the conversation a little bit?
Yeah, so I think it's like really important to understand that when we traditionally think of like a shift in technology, we're thinking about how we've moved from mainframes to personal computers, and from personal computers to phones, or from traditional applications to like SaaS-based applications. It's extraordinarily important to understand that with quantum, it's really not about like a replacement, right? We're not talking about that quantum chips are going to replace like your laptop or anything like that. What it's really about is really about solving problems that are stomping even like the most powerful classical systems. Think of it like as a supercharged calculator, or something that can be used as a way to design new drugs or secure financial portfolios and things of that nature. There are a couple of examples that I can go into. One example is like the supply chain management. So in this space, you can think of like quantum algorithms that can analyze like millions of different routes, different weather parameters, of delivery schedules. If you're shipping something globally, or you're trying to make sure that your factory is working at its peak optimization, you don't want to store supplies, you don't want things sitting on ships, you don't want things sitting in ports, you want to be able to route around hurricanes, you want to be able to route around logistic chain problems at ports, that type of thing. And so you need compute power that's going to be able to do all of those things at the same time, and still cut costs by doing that. So within the supply chain management thing, quantum algorithms that are running on quantum capable infrastructure would be an ideal kind of use case for that. In pharmaceuticals, you can do quantum simulation models, like on the molecular interaction. So understanding, protein designs and all of that kind of stuff. That's an area where pharmaceuticals will gain massive advantage, because instead of running these types of compound algorithms that would take weeks, months to run on a quantum type environment, those things could be reduced to days or hours.
Wow.
In finance, quantum systems can optimize portfolios and detect fraud, right? So they're looking at pattern recognition, things, not just pattern recognition, but imagine in a fraud environment, what you're looking for is location-based data, spending habits of an individual, what are all the threat markers that are being published by various institutions, and combining those at lightning speed to detect fraud within individual accounts when you're dealing with billions and billions of accounts, right? So those are the types of things that quantum is going to be able to do. It's going to be able to solve those multi-layered complex equations much faster than traditional workloads. Even though we have like multi-threaded processing power, and GPUs are able to do things like that as well, being able to attack those problems and have all of those variations in those problems really fall towards like a quantum workload.
Wow. Yeah, thank you for sharing that. And one question I had is, with your background in developing network systems for telecos, and using the geospatial mapping, and kind of thinking about the network, and building on top of those networked layers, like what would you say? Are there any similarities between kind of that network space and how quantum might like manifest?
So quantum will have massive use cases and deployments within the telecom industry for a couple of reasons, right? One is, generally speaking, the telecom answer to service outages or service needs has been to add additional service, right? So in your mobile 5G deployments, it's add more antennas. In your fiber to the home, it's add additional pipe capacity, that type of thing. But as we've converged onto utilizing more and more data, I mean, I can remember one of my earliest cell phone plans, probably in 1997, might have had a data element to it, and there might have been 240 kilobytes of data, whereas something in 2008, like 40 megs of data at the time. To today, it all being very unlimited, and being unlimited for a specific reason. There is very little gauge of how much data you're actually going to use based on the types of interactions that you're making, right? So if a kid's sitting on YouTube all day, or if they're playing video games, or if a person is using their phone as their primary communication device for work, all of those workloads have very, very different data uses. The only thing that we do know in the telecom industry is that the data uses increase year by year exponentially, because we're adding on not only more data as a user, but we're adding on more devices as a need, right? So now all of a sudden we all have at least a Ring camera, but we probably have 3 or 4. We all have our cars connected to our systems. We all have refrigerators and ovens and microwaves and all of those kinds of things that are collecting data, utilizing a bandwidth and all, and kind of demanding unlimited versions of that, because we also need to update those, firmware on those things, and so it's bidirectional. It's not only like downloading data. So to be able to provide those types of services and to be able to scale those types of services, what the industry is looking at is how to improve the current hardware that they have. Like in the cable industry, there's something called DOCSIS, and there's DOCSIS 1, DOCSIS 2, DOCSIS 3, DOCSIS 4, and most cable operators today are operating on the DOCSIS 4 technology type. But that DOCSIS 4 technology type only provides, at a maximum 900 megabytes down, and maybe 100 up, and that's really great DOCSIS. But more recently, they've been able to figure out how they could provide multi-gig bidirectional bandwidth on DOCSIS 4, right? DOCSIS 4S, or I forget what the acronym is for it. To be able to do that, they had to imply limitations on how the stuff is routed internally. And to do that, you're talking about billions and billions of transactions on a minute by minute basis. No human can do that, right? No team of humans can do that. Applying AI to do that is the only way to do it. The next level of that, as that becomes even more complex, is to apply some of those workloads as you start to, agentify the AI, moving those agents onto a quantum platform will significantly improve the ability to do that switching. It's happening within the 5G realm. It's going to happen within 6G as the next platform. And in those types of platforms, it won't be things that we're taping on to the standards of the technology. It'll be stuff that's built in the core of the technology, and being able to move that workload off the core of the technology onto a quantum platform will be the kind of in-between step. Ultimately, as we get to 2035, as we get into 2040, that stuff will be, the quantum will be core integrated into it as well.
Yeah, that's a fascinating use case, and I can really see how the industry is going to be shifting. And so, kind of looking at all the different research that you tend to do, and your column and what you write about. We have quantum, AI, infrastructure, edge computing. These are all frontier technologies. Some are more mature than others. Some are more frontier than others. What would you say is like the underlying shift that you feel like ties all this together, and what motivates you to write about it?
So, like I said at the beginning, the reason that I started writing the newsletter was really to kind of figure, partially was to help some of the students that I've had over the years, and partially was to help myself, kind of stay ahead of the game, right? So, one of the ways to stay active and modern and understanding technology is really to try to research it and then to write about it, right? What's the old saying? You don't know anything unless you can explain it simply, and if you can't explain it simply, you don't really know it. So that was my initial goal with it. The other goal with it is that I think that there's a lot of fear from a technologist perspective. People, the men and women that are working in this field kind of feel to some extent that in one direction you're hearing about the superstars of AI getting a baseball player or football player or soccer player salaries to join the open AIs of the world. But on the other end of it, you're hearing that there's massive layoffs happening, or that there's companies like Salesforce which are saying like, we're not going to hire engineers going forward because we believe our agentic AI is going to take over those jobs. And to me, a lot of that is just marketing. It's ways of making someone else rich, right? If I can make a huge statement saying that AI is doing these stuff and then grow my stock price, all the better to me. But it's not real, right? What is real is that there are shifts, right? AI is able to write code. The code that it writes, in some instances is great, and in a lot of instances is not so great. But the thing to keep in mind is that, originally, 20 years ago, we would have said, hey, you want to start up, you got to buy infrastructure, you got to set it up, you got to have the rack, you got to get a bunch of engineers, and you got to worry about like what your technical debt is. In today's environment, you have the cloud, right? So you no longer have to buy infrastructure. You have a lot of tools already. Stack Overflow was great, and GitHub was great for a lot of open source tools. Things that we had to build when I first started are already there, right? So you're halfway there. And so the approach to the problem has shifted significantly, right? It's been a tectonic shift. It's shifting again. If startups can go to tools like Zipfer or NHN or Bolt.new or these things to develop MVPs or proof of concepts, they're going to do that first. They're not going to hire engineers to do that. But it's not as simple as but at the exact same time, there are very few people that can just go to one of these websites, create an account, and launch a product. There are still things that need to be tied in. There are APIs, there are deployments, there are a whole host of things that someone needs to understand to do that. And because of that, I think that there's a massive opportunity for a new type of role that's going to emerge, or that is already emerging. And in my newsletter, I call it intelligence orchestrator. And what I believe that role is really someone who has a couple of capabilities, right? It's a person who has some technical capabilities. So they've done some type of coding in the past. They've done some database administration. They've done some system administration. They have all of those kinds of skills so that when they're on one of these Zipper pages or something, they understand the language that's being presented in front of them. On the other end of it, it has to be someone who has some data analytics skills, right? All of our applications today, all of the things that are being built are using heavy amounts of data, right? You can't automate if you don't have data supporting those interactions. So they need to be, they don't need to be a data analyst, but they do need to have data analytics understandings, right? And then finally, they have to be someone who's versed in the world of commercial business, right? So think more product manager than project manager, someone who can understand what the costs that are going into the processes and what the ultimate benefits that will come out of the business are. And this person needs to orchestrate all of those things as we move from moving infrastructure, into the cloud, into AI, into quantum, into other things that are coming shortly.
Nice. Yeah, thank you so much. You guys, viewers, you heard it here on Megashift and Tectonic Shift, Intelligence Orchestrator, the new role that is emerging in this context. Well, it's been a really amazing conversation today, Mario. As we wrap up, is there anything else you want to share, or is there anything that you think business leaders are kind of missing cues on that they need to be thinking about as we look at these future technologies expansions? What would you say to business leaders, and is there anything we haven't discussed?
Yeah, I mean, the thing that I would say to business leaders and people who are in the information space is that there's a lot of noise, in the marketplace right now. There's a lot of hype. There's a lot of misunderstanding of capabilities and that type of thing. But the truth is that there really is a shift, right? Things are fundamentally changing, and how we approach those changes will define what the next 10 years look like in our own careers and our own capabilities. And so being able to get through all of the hype and understanding the underlying pieces, understanding what AI is, what it's capable of, how to engage with it, how to build small POCs across your projects, understanding quantum, understanding what it is and what it is not, understanding what the potential harm could be from it, and then also understanding what the potential benefit could be from it, I think is highly, highly important. And being able to start to, if not create strategies, start to utilize frameworks for how you will create strategies. 2026 will be a massive year in technology. These kinds of massive, cloud, AI, and quantum will converge fully. What I mean by that is you'll have full workloads running of all three things on, off-prem machines, doing real workloads for your organizations, and getting in front of that with a framework, I think, is highly, highly important.
Nice. Yeah, well, thank you so much for your time. Is there anything else that you'd like to share?
No, just thank you for having me today. It was a great pleasure.
Awesome. Well, thank you, Mario. So you heard it here, folks. Mario Camaj from Tectonic Shift on Megashift today. Thanks, everybody.